Let's now talk about solving one-step equations. An equation is basically a mathematical statement, and in that statement it's going to show that two sides of the equal sign are going to be equivalent. They're going to have the same value. So let me write that out for you. It's a mathematical statement that shows two expressions as equal. And an example would be, really easy one, 2 plus 3 equals 5. Because 2 plus 3 is also 5, and 5 equals 5, you can see that both sides of the equal sign have the same value, or they're equal. Another way you could write this as, maybe different problems. 3 times 4, well, that's going to be equal to 2 times 6. Both sides of the equal sign are going to have the same value, in this case 12. Well, sometimes we have equations that have variables, and a variable is a letter that represents a number that we don't know at a given time, and oftentimes we follow some rules to figure out what the value of that number is, and that's sort of what we're going to be looking at today. So sometimes you actually, and you can have more than one variable, but in the cases that we're going to talk about today, we're only going to have one variable. So let me give you some examples. So say we have 7 plus a number, and that's going to equal 13. Now in this case I'm using n, but you can use any letter when we're talking about variables. Most common letters are x. In this example I used n, but probably for the other examples I'm going to mix it up and use some other letters. And basically what we're going to try to do is figure out the value of this variable n. And you can probably figure out that n is going to equal 6. And we'll show you, or I'll show you here in a minute, how to get about that. But basically, 7 plus 6, that is going to give you 13. So n has to equal 6 in this equation. Let's look at another. Let's say here we have x minus 3 equals 21. And if you thought about it a little bit, you could probably figure out that x is going to equal 24. Because 24 take away 3 will give you 21, which is the value on this other side of the equal sign. And there are other kinds of one-step equations. You might have something like 5m equals negative 35. And you can think 5 times what will give you negative 35? Well, you might come up with m equals negative 7, because negative 7 times 5 will indeed give you negative 35. And then there's another problem that we'll come across in our examples today. For instance, if you have your variable in a fraction, like say t divided by 5 equals 3. Well, you can think about, well, what number divided by 5 will give me 3? And you might come up with 15. 15 divided by 3 will, 15 divided by 5 will give me 3. Now in all of these cases, these equations were rather simple. We could kind of easily figure out what the answers were by just thinking about the problem. But oftentimes you're going to be given numbers that are not as easy to figure out, and what you want to do is follow some rules so that you can solve for your unknown variable, and it will work every time if you follow those rules. So let's go ahead and look at some of those rules. And really, it's pretty easy to remember. The goal, of course, is to isolate the variable. What that means, isolate, means all by itself. So on one side of the equal sign, you're going to have the variable, and then on the other side, you're going to have a value, and that value is going to represent the variable. If you were to plug in that value for the variable, your mathematical equation would be true. Now, we're going to get to isolating the variable by using inverse operations. Inverse operations. And we'll go over how this works in a minute. The other thing is, if we do one operation to one side of the equal sign, we have to do it to the other side, or else we're going to change the equation, the original equation. So I like to call this keep the balance. But basically, if you can think of a little scale here. If I were to add a box here, that would make this side heavier, and then all of a sudden, this side is much heavier, or this side is lower than this side. But if I want to keep this an even or an equal mathematical statement, if I add a box here, I need to add that same size box on the other side so that I get an equal or a balanced equation. The last thing that I always recommend is, once you get the value of the variable, plug it back into your work and check to make sure it worked out. So I always call that check your work. Now we're going to go through some examples, and I'm going to use these steps so that you can see how it works. Let me get another pen. All right. Let's begin. Say we start off with x minus 15 equals 10. Now, my goal, of course, is to isolate that x, and I'm going to do that by using inverse operations. Inverse means opposite. So the opposite of subtraction would be addition. So I'm going to add 15, and because I want to keep the balance or do the same operation on both sides, I'm going to add 15 on the other side of the equal sign. X, and now I have a negative 15 and a positive 15. Those essentially cancel out, so I'm left with equals, and then 10 plus 15 is 25. So the value of x is going to be 25 in this case. Now I want to do that last step. Check your work. That means I'm going to plug in that 25 whenever I see an x. So if I go 25 minus 15, well, 25 minus 15 is going to give me 10. So 10 equals 10, and that is correct. That's a true statement. Both sides show the same value. Let's do another problem. Let's say we have x plus 14 equals negative 5. Again, I want to use inverse operations. The opposite of addition is subtraction. So I want to subtract 14 from both sides. Bring down your x. Positive 14 and negative 14 cancel each other out. I'm left with equals, and negative 5 combined with negative 14 will give me a negative 19. Now I want to plug that back in. So I'm going to actually do it below. So if I go negative 19 plus 14, Negative 19 plus 14 is going to give me a negative 5. And that's what I had up here, a negative 5. Let's do some other kinds of examples. Let's say we have, so in these first two, we had the variable up front. Let's have the number up front. Let's say we have 9 plus x equals 21. Now, this is actually a positive 9. Even though we don't have the symbol or the sign there, we're going to assume that's a positive 9. So the opposite of a positive would be a negative. So I'm going to subtract the 9 from both sides. That's going to cancel. I'm left with a positive x, or just x. 21 take away 9 is going to give me 12. Now if I were to plug that back in, 9 plus 12, I would get 21. And that's what I had here. So 21. It worked out. Let's do some more problems. In this example, we have negative 2 plus x equals negative 16. This is a negative 2, so the opposite of negative 2 would be a positive 2. Add 2 to both sides. That's going to cancel. We're left with a positive x, or x. Negative 16 plus 2, that's going to give me a negative 14. Now if I plug that back in, I'm just going to rewrite negative 2 plus a negative 14 is a negative 16, which equals the other side of my equation, or the other side of my equal sign. And so I would say that that is indeed the value of x for this equation. Now let's look at some multiplication and division problems. Here we have 4x equals 24. Now, what we want to do is identify the operation that's going on between the 4 and the x. If you don't see a symbol like a plus or a minus, or even a dot or a parentheses or a division sign, you can assume when you see a number right next to a variable that that is going to be multiplication. So the opposite, or the inverse operation for multiplication, is division. So we're going to divide by 4 on both sides. And the reason I'm dividing by 4 is I want to isolate the x. I want that all by itself. So I always want to divide by the number I want to get rid of. So I'm going to divide by 4 on both sides. 4 divided by 4 kind of cancels each other out. So really this is 1x, but we normally don't write 1x. We're just going to write x. Now 24 divided by 4 will give me 6. Now if I want to check my work, which I advise to do, you go 4 times 6 equals 24. 4 times 6, well, that's 24. And you can see that those two have the same value. So in this equation, x equals 6. Let's do another one like this. Let's say we have negative 3x equals 39. Again, this is multiplication. Negative 3 times a number equals 39. So the opposite would be divide. And again, we're going to divide by the number that we want to get rid of. We want to get rid of negative 3. And we're going to do that division on the other side. So divided by negative 3. These two are going to cancel, and we're left with a positive x, or just x. And now we're just dividing. 39 divided by negative 3, well, that's going to give you a negative 13. So if I want to plug that back in, negative 3 times negative 13 should give you 39. And if you're not sure, 3 times 3 is 9, 3 times 3 is 1, so that's positive 39, because two negatives make a positive when you're multiplying. Because these two numbers are the same, this is the value of x for this equation. Now let's do a couple more problems in which we're dividing. In this problem we have x divided by 4 equals negative 5. It looks like a fraction here, but if you're thinking of just operations, the operation that's occurring is division. We're dividing x by 4. Now, the inverse of division is multiplication. And here's the thing, when you have a problem that looks like this, like a fraction, which is really division, what you want to do is multiply the number or the value that's in the denominator. So we're going to take this 4 and we're going to multiply it to both sides. So I'm going to rewrite it. We're going to have 4 over 1 times x over 4. This was our original amount, x divided by 4. We're going to multiply by the number or the value that's in the denominator, which is the 4. Because we're multiplying by 4, we also want to multiply by 4 on the other side of the equal sign. Notice over here I wrote it out as a fraction, 4 over 1. Because this side is not written in fraction form, I'm just writing it as a 4, and that's okay. We can cancel these 4's, and we're left with x over 1. Negative 5 times 4 is negative 20. Now x over 1 is just going to be x. So x equals negative 20. So if I plug it back into this original problem here, if I write negative 20 divided by 4, that should give me negative 5. And if you think of it, negative 4 divided by, or negative 20 divided by 4 should give you negative 5. A negative divided by a positive is a negative. 20 divided by 4 is 5. That indeed is equal to our original answer. So, I feel pretty confident that negative 20 is the value of x in this equation. Let's do one more. Let's say we have x divided by negative 3 equals 12. So a number divided by negative 3 is going to give me 12. Again, we're going to do the inverse. So the inverse of division is multiplication, and we want to multiply whatever is in the denominator. So negative 3 over 1 times x divided by negative 3 equals 12 times negative 3. We can cancel these negative 3's. We're left with x over 1, which is going to just give us x. 12 times negative 3 is negative 36. And if I, excuse me, if I plug in the negative 36 into my original equation, I should get 12, positive 12. Remember, a negative divided by a negative will give you a positive, so 36 divided by 3 is 12. And that is equal to 12. So for this equation, x has the value of negative 36. So hopefully you can see that it's pretty easy in these one-step equations to isolate the variable. And we do that by using inverse or opposite operations. And if we do an operation to one side of the equal sign, we have to do it to the other side. And the last bit is to take your answer and plug it back into the equation, just to make sure that you did the math correct.